All right, Chem One Nation, are you ready for more density? Could you have guessed that?
We're
All right,
ready.
We're ready. All right, well, what do we have today? Mr. Moore has these two spheres. They are both made of stainless steel. So the same material makes them up. Okay? So I'm going to put the smaller one on the balance here. It's about 149 grams or so.
Yep.
Now, what do you think? Should it float? Sink?
Well, it's metal.
It's metal, so
Yeah,
I
yeah,
guess.
most of those will sink. won't
Duh.
they?
I mean,
Yeah.
I'm thinking it's going to sink, right? So let's just verify that. I'm going to add to this beaker, and I'm going to run it down the side gently because I don't want to crack the beaker. I'm actually going to put my hand in, I think.
Yeah,
It's pretty heavy.
It's heavy, yeah.
And I'm not too surprised.
Wow, so it sank.
Wow, it's stunning. The things you learn in chemistry. Okay, so here's the other one. Okay, do the same thing. We'll put it on the balance.
How does the mass of this one compare to the one before it?
I believe it's greater.
It's a heavier mass.
It's about 162. The other one was 148.
140 something, yeah.
So it's a little bit heavier. So what's going to happen? No brainer. It's going to sink.
Heavier mass made
Come
of the
on.
same stuff.
Yeah, it's got to sink. What? I mean, it's.
All right. Well, yeah, maybe we just need to push it down there and help it out.
I mean, yeah, it's floating big time.
Yeah, it is very resistant to sinking.
Yeah, I mean, I can push it all the way under, but it leaps back to the top.
It looks like you're having a good time with it.
I really am, actually. Maybe I could get a set of those for my birthday or Christmas.
Students, remember that.
Yeah, okay.
Okay, so yeah, we did ask for you to give an explanation why, if they're the same material and pretty close to the same mass,
Pretty close.
why do we observe that?
Okay.
What else do you have?
Well, let's see. We have a blue liquid here.
Can we do them in order? Let's make it easier
Oh,
on
sorry.
our
What's
students.
supposed
Let's
to
do
be
the
next?
wood
The
block.
block, sorry.
Yep, no, that's okay.
All right, so scratch that. We've got this wood block, and so we're going to try to get the density of this. So we're going to try to let you use the ruler to make your own measurements. I should put my glasses on. And is this sitting in a way that they'll be able to see it?
I think we'll be able to see this great, yes. Okay, students, we remember how we make a measurement with a ruler now. We got 0 over on the left.
Is there too much shadow?
There is a little bit of a shadow. And if I move in too much...
Could I hold? What if I did this? Could I do
Yeah,
this?
but that's better. If I could just hold the iPad steady, we'd be
Yeah,
all
it'd be
set.
easier, right?
Do the best you can with that measurement.
You know what I found is I hit pause now in these videos, so I can actually.
Oh yeah,
read it.
while you're playing it back.
Yeah, I hit pause. That helps a lot. Okay.
Okay, how about a width? I think we can read that 2 places past the decimal. Students?
Okay, last one.
Mr. Hevel's a physics guy, so he knows his lengths, widths, and heights. Oh boy, that one is pretty close to a whole number.
Yeah.
Okay, so what does that? So we know length, width, and height.
Yep.
We have something.
Should be helpful. Okay, let's see if we can get the mass of this thing.
And a mass. So let's get the density of that wooden block. When you get a density, let's think about it. Does that make sense? What should the density of a wooden block be? I think we have enough real life experience with wood to know.
Yep. Think
If
about
our
how
answer
it
would-
interacts with waters.
Yep.
Kind of what you're thinking.
Mm-hmm.
Okay, next up we have this metal cylinder.
Oh, yes.
Now we've been doing a lot of water displacement
Mm-hmm.
to get volume, but we thought today maybe we could just use some dimensions of the cylinder and calculate the volume. So,
Everybody here likes math, right?
yeah. Always remember you learn math to do better science.
Is there another reason to have math?
I can't think of one,
No.
but you know,
Same here.
that's me. I don't know, Mr. Moore. I hope the shadow is
so-
not.
I think we can read that. Okay, so there's what? We call that the height of
Height-
the cylinder,
Height
right?
of the cylinder, yep. And I think we can get the diameter.
Okay.
Let's try that.
We're just gonna have to settle for close on this, I think, because
Yeah. Oops, that moved.
Yeah,
it moved.
okay.
Okay.
All right, see what you think of that. Oh, let's get it out there.
Oops, I think it moved again, Mr. Moore.
Can you see it okay?
Is that okay? Is it visible?
Remember, this is the diameter.
Yep. Did you learn the equation for the volume of a cylinder?
I think our students did.
I think they did. Okay, now you'll probably want a mass.
Looks good. Find the volume of that piece of metal.
To the correct number of significant figures.
Yes, please.
Okay. Now next we have Mr. Moore's mysterious blue liquid.
That's even what the bottle says,
It
isn't
is. It's mysterious.
liquid.
Blue liquid, indeed. So, let's see. How are we going to do this, Mr. Moore? Are we gonna get the mass of a certain volume of this, or
Well, to find the density, we would need the mass and the volume.
okay?
What do we have for tools here? Well, we have this for a mass. And how can we get the volume of a liquid? Now, do we have to use that whole sample of the mysterious blue liquid or just part of it?
I bet we don't. Well, I mean, I could do this. I'll give you two options.
Oh, okay. I like options.
Okay. And then what you should do maybe is pick the one you think is the best. Okay, so let me put the beaker on here. Okay, we'll zero the balance. Oops. Oops. One second, I did pretty well on pouring, except for 2 drops it off.
So you had zeroed out the mass of the container.
Right.
We just have the mass of the mysterious
And
blue
then, I don't know, can you read? It's blue on blue, trying to see the liquid volume against the graduations.
Oh, yeah, oh, yeah.
Is that showing up?
Not very well, but let's see. I may be able to zoom in on that. You can see. Oh, yeah, that's nice. Okay.
Okay, there's one option for you.
Okay, I see a volume there on the beaker. Beaker, that is.
Yeah. Or another thing, because Mr. Moore had the cylinder handy, I could I could repeat that, except,
Yeah, that was giving me trouble earlier.
okay, so now we've zeroed the balance out with a cylinder on there, graduated cylinder.
Okay, I'll step out of your way. We can see what you're doing. Okay, so what have you done here? You have a mass of some liquid. Not all of it, because some of it's still in the container.
Yeah, it won't all fit.
Okay,
So I just dumped some in.
so there's a mass, and
It's probably close enough. Just call it 10, right?
students, we know better than that. Can you read that volume
Is it
measurement?
visible? Do we need a
It's good.
background?
No, I think it's good. We can read that, can't we? Okay, get the volume of that,
Okay.
and you have its mass.
Yep.
Find the density of that liquid.
As accurately as possible.
Mm-hmm.
And we'll have to save the mysterious blue liquid for the next time.
Could
Mr.
be-
Moore
could
won't
be
even
next
tell
year.
me where it came from. I have no idea where this came from.
Okay, we have one more thing, and I actually put it over there, Mr. Hevel.
Okay.
You remember that one.
Oh,
Here's
yeah.
a good challenge for our Chem One Nation.
Indeed.
What do you have?
This is the best one. We have a piece of aluminum foil.
Yep.
Okay. And the question is, how thick is this sheet of aluminum foil?
Come on.
And I mean, I could try to measure it, but that clearly is going to be impossible to do.
Yeah,
I mean, trying to measure the thickness with a centimeter ruler, give me a break.
that's pretty thin for the ruler.
That's pretty thin. That's a good joke, Mr. Moore. It's awful thin. Okay.
Yeah.
So let's see. Maybe we could get the other dimensions, though.
Okay.
All right.
You mean the foil has some volume? As flat as it is, it actually takes up some space?
Oh, yeah, absolutely, it does.
Okay.
Yep. It's just not very big necessarily.
Okay.
So what do you think? We could get two of the dimensions,
Okay,
right?
let's try that. So it's 0 over there up to the... Let's get that length, okay?
Okay. Let me turn it for you.
Again, 0 and... All right. So what do we have? We have the length and the width.
Yep.
Of
We'd
the
like to
foil.
know the thickness. I wonder if knowing the mass could be of any use.
Well, we have the balance out. Let's just throw it on the
Okay,
balance.
all right. Now, if I do this, is it going to drape? Oh, no, I thought maybe it'd drape over it. Oh,
Was that 0
Was it
now?
0?
Let's scratch that measurement.
It wasn't 0.
Okay.
It was still the
Seems like
mysterious-
more than 20 pounds of aluminum.
Yes. There we go.
I said more. Yeah, it seems like less.
Yeah.
Oh,
Ah,
okay.
that's better.
Okay. So we have a mass of the aluminum. We have the length and the width. Could we use that data to find the thickness of the foil?
Might be able to. Remember, this lab is about density.
Oh, yeah.
Density might help us.
And this is tin foil, right? Tin foil?
I believe it's aluminum.
Oh, it's aluminum foil.
Aluminum foil.
Okay. Okay.
Aluminum foil. Yes.
All right. Well, let's see what we can do with that.
Okay.
And do we have anything else to measure? I think that's it, isn't
I
it?
think that's it.
Is that enough to practice some density?
Yeah, I think so. You know, that last question there, Google could be your friend. You might need to look something up to help yourself with that aluminum foil question.
All right, Mr. Hubble, we're going to give this a shot.
All right.
Thank you.